We'll see a question so that you'll understand how to do. Find the power dissipated in the resistor R in the ladder network shown in figure. Choosing the loop currents I1, I2, I3. See, clockwise direction, take all clockwise direction. If they don't mention any direction in the question, take a clockwise only. If they mention the direction, you should consider that direction only. But if they are not mentioning, take clockwise direction only so that it will be easy for calculation. Take it. Then what we need to do? We need to write KVL equations I1, I2, I3 for to calculate. What is the KVL for? Apply KVL for what? First mesh. We will write 1 here plus minus plus minus. If you consider 1 minus 1 I1 minus 1 I1. Why? R into I. Nothing but voltage drop across resistor. So 1 into I1 minus 1 into I1 minus I2. Why? Because they are considering first mesh. So we need to minus I1 current minus I2. Why? Because both currents are moving through resistor. We need to consider both currents. I1 minus I2 equals to 0. If you rearrange, you will get 1 equals to 2I1 minus I2. And then we'll see the KVL for second mesh. In the same way, what we'll do, first we'll write, again we need to consider the currents, no? Plus, minus, plus, minus, plus, minus. Consider in this way now. After considering, what we need to do, 1 into I2 minus I1. Okay, then just 1 I2, then 1 into I2 minus I3. If you rearrange this, you will get minus I1 plus 3I2 minus I3. Okay, then what we need to do? The third equation we need to find. What is the third equation? For third equation, we will consider the third mesh. 1 into I3 minus I2 plus I3 plus I3 and plus I3. Why? Because both have only one current, I plus 1 I3 plus 1 I3. 1 into I3 minus I2 equals to 0. If you rearrange, you will get minus I2 plus 3I3 equals to 0. Okay. After doing this all, we need to find I1, I2, I3. We need equations. So it is in the form of I1, I2. If I3 is not there, you need to consider 0 I3. Remember this, 0 I3 need to consider. Okay. Here all the three components are there. Here I1 is not there, so consider 0 I1. Okay. After considering, if you solve these three equations, then what you will get? I2 as 3 by 13. Then power, if they want power in the resistance R in the ladder network. Resistance R in the ladder network. They want the power in the resistor. If they want the power in the resistor, what we need to do? We already know the I2. I2 is what? I2 square. Power will be equals to I square R. If you remember the formula, I square R. I square is 3 by 13 whole square. That is nothing but 9 by 169. R is anyway, it is 1. 1. So 9 by 169 is the power. Power in the resistor in the ladder network. So in this way we will find the mesh currents and how to do mesh analysis. I hope you understood. Why? Because while mesh current we take KVL. KVL will put for all the meshes. You should know KVL very well while doing this. Then alternate method. We have seen in the before slide the Cramer's rule. No, I'll show how to do using Cramer's rule now. These are the 2-3 equations we got already. I've put once again here. These equations, what can we do? We can write in matrix form. See here. I1 component is 2. I2 is minus 1. I3 we don't have, so 0. I1 is minus 1. I2 is 3. I3 is minus 1. For my 0, I1 there is no 0. I2 is minus 1 and I3 is 3. Okay, then what we need to do? We need to multiply the matrix I1, I2, I3. Why? Because it is V into, that is Z into, or R into I equals to, sorry, and this is R into I equals to V. So it is in this form. So we need to write in that way. After writing, here if you see, the right hand side is equals to 1, 0, 0. 1, 1, 1, 0, 0. Okay. After writing this, we need to take the Cramer's rule. We want mesh current I2 to find. Okay. To find mesh current I2. Why? Because they are asking power dissipated in R equals to 1. The same Cramer's rule can be used to find I1, I2, I3, but I am showing only for one current, that is I2. How to do? How to do I2? I2 is equals to delta 2 by delta. Delta 2 means what? Delta, first we'll find delta. Delta is what? 2 into 3 3s are 9. 9 minus 1 1s are minus 1 into minus 1 is plus 1. So 9 minus 1. You will get this. Then you should consider minus 1 we got. That is, we need to take this. If you remove, then you will get minus 3. Now we need to consider what? I think you all know matrix, how to find. If this is not there, then what is this? 3 minus 3 minus 0. So you will get minus 3 minus 0 plus, as it is 0 0 into 0 into what we will take. Now we will consider, you don't consider this column, then my 1 minus 3 into 0 is 0. 1 minus 0. If you find in this way, you will get the matrix. How delta is equals to 13 you will get. After getting delta is equals to 13, we need to find delta 2. Delta 2 is what? Delta 2 is nothing but, you want I2. I2 means what we need to do? We need to replace this second column with 1 0 0. This right column. How we will, now we will see how it looks. 2 minus 1 0. This second column, the second column is replaced by 1 0 0, and third column is same, 0 minus 1 3. 0 minus 1 3. After doing this, what we need to do? 2 into, we need to find delta of this again. 2 into 0 minus 0, then minus 1 into, we need to take minus for the second column. I think you know the rules of the matrix. So minus 1 into minus 1 minus 3 minus 0, minus 3 minus 0 plus 0. 0 into 0 minus 0, anyway delta 2 will get 3. I2 is equals to 3 by 13. I think if you see the previous slide, previously what we got is 3 by 13 itself. For finding resistance, what we will do? The power in resistor is I square I2 square into R. I2 square is what? 3 by 13. 3 by 13 is nothing but 9 by 169. R is anywhere here it is. R is anywhere here it is 1 ohms. So 9 by 169 is the power. So we'll go to the next sum.